Today we are going to discuss about some of the basic concepts of physics and which will be helpful for class 11 students such as momentum, conservation of momentum, frictional force, inertial frame, non-inertial frame, torque, angular acceleration, angular velocity, angular momentum, work done, kinetic energy, potential energy. All this about this I'm going to discuss today. I'm going to discuss about the basics concept. Momentum, as you know, that it is mass into velocity, and the momentum is conserved. That means when there is no external force, your momentum is conserved. As in case of elastic collision, your momentum is conserved. That is, momentum before collision is equal to momentum after collision. Let us explain it a little bit further, and this example will be easy for you to understand. When you throw a ball upward, the momentum of the ball decreases, but at the same rate, the momentum of the earth increases. So your momentum is conserved because the force of attraction between the ball and the earth is the same. Similarly, when we fire, the bullet experiences a large momentum. At the same time, the gun also experiences a momentum in the backward direction and we get a kick. That is, your momentum is conserved. This is also an example of Newton's third law. Now we come to the friction. Here we see the friction does not depend on the contact area. It depends on the weight of the body. So we know that friction is equal to coefficient of friction into normal reaction. Normal reaction, that is the weight of the body. So friction depends on the weight of the body. Now we come to the inertial frame and non-inertial frame. Inertial frame, that is, it obeys the Newton's law, that is law of inertia, where the velocity is constant or the body is at rest. Now suppose if a body is accelerating and the person inside it is a non-inertial observer, because the frame is a non-inertial frame because it is accelerating. For an inertial frame, your acceleration must be zero because your velocity is constant. And similarly, if a body is moving with constant velocity and the person inside is a an inertial observer because your body is moving with constant velocity, it is an inertial frame. So the person inside it is an inertial observer. So let us explain it further by giving you an example. You have seen a truck and let the truck accelerate towards left. When the truck is accelerating towards left and a box is placed on it, since the truck is accelerating, therefore the box is a non-inertial observer. That means your truck is in non-inertial frame. So your box is a non-inertial observer. And the force a pseudo force will act on it, and it will act towards the towards right, and the frictional force, that is the contact force, will act towards the left. So I'm repeating the example again. That is, if a truck is accelerating towards left and a box placed on it will experience a pseudo force towards right, and the friction between the contact surface will act towards left. Similarly, say there are two blocks A and B. A is above B, and both the block is lying on a table. A is above B. Now we apply a force on B towards right, and it is accelerating. So for box B, it will be a non-inertial frame. It will be a non-inertial observer, and the pseudo force will act towards left, and the frictional force, that is the contact between the contact of the two blocks, will act towards right, and this frictional force will try to keep the block A, which is lying over B, to move along A. So now I think so it is clear about inertial frame and non-inertial frame. So in case of linear motion, there is linear momentum and force which acts in the direction of the motion. Similarly, in circular motion, torque, it creates a rotating motion, rotational motion. So torque, it gives angular acceleration because torque is equal to moment of inertia into angular acceleration. When your torque is zero, your angular momentum is conserved. That is, let us take an example. Earth is moving round the sun. It is revolving round the sun. The earth is revolving round the sun about its sun axis. Here we find that the torque is zero. Because the force of attraction between the sun and the earth is along the radius vector, so your theta is zero, so your angular momentum is conserved. Now, if the earth shrinks, what will happen? Since your angular momentum is conserved, and angular momentum is equal to moment of inertia into angular velocity, so when the earth shrinks, that is its radius decreases, so its moment of inertia decreases. And as its moment of inertia decreases, its angular velocity increases. So when its angular velocity increases, that is equal to angular velocity, we know that it is 2 pi by t. T is the time period. So we find that as the angular velocity increases, your time period decreases. So when your time period decreases, the length of the day decreases. Similarly, when firing, while firing, the bullet experiences a large momentum. So this is not angular momentum. This is the case of linear momentum. So let us, at present, I must not talk about it. Again, a flywheel. A flywheel, its whole mass is along the rim, which is far away from the axis. So its moment of inertia is large. And when flywheel is rotating, what happens? Moment of inertia, that is angular momentum, is conserved. So since its moment of inertia is large, its angular velocity must be small. And since the angular velocity is small, the body can move smoothly. Again, I want to tell you about conservation of angular momentum. That is, if a ring is rotating about its axis, its angular momentum is conserved. Now, if a small part of it get eroded and moves out, its angular momentum will remain conserved, but its angular velocity will increase. So here we find that when torque is zero, your angular momentum is conserved. So the angular momentum is conserved, but angular velocity is not conserved. So these are the important facts. Now again, uh, let us come again back to linear momentum, because I am correlating this angular momentum and linear momentum. When a gun is fired, the bullet experiences a large momentum. At the same time, the gun experiences the same amount of momentum in backward direction. So we get a kick because your linear momentum is conserved. This is also an example of Newton's third law, no doubt. This is also an example of Newton's third law. So here, I think so, you are clear with the conservation of linear momentum and angular momentum, because these two are very important for solving, these concepts are very important for solving problems. Now, let us come to energy. Uh, if there is a friction, a body is moving with some velocity, and if there is a friction, there is loss in kinetic energy. There is a loss in kinetic energy. And again, if two protons comes nearer, its potential energy increases because of repulsion. But if a proton and an electrons come nearer, its potential energy decreases because of force of attraction. Now again, potential energy can be negative, and if potential energy is negative, it means there is attraction, because we know that the potential energy, uh, we know that in case of potential energy, negative means attraction. That is, again, if work is done against friction, then there is loss in kinetic energy. Now, um, about work done, zero work done, because we know that work done is force dot displacement. So let us take an example. If or if an artificial satellite is revolving around the earth at some height, the work done is zero. Why the work done is zero? Because the gravitational force, it acts towards the center and your motion is tangential. So motion is tangential, that is displacement is tangential. So the angle between the force and displacement is 90 degrees. So your work done is zero. The work done by the gravitational force is zero. So when your work done is zero, that means your kinetic energy is constant. And when kinetic energy is constant, that means that the satellite is revolving around the sun with a constant velocity. With a constant, instead of velocity, let us say with a constant speed. So here we find that work done can be zero, work done can be positive, work done can be negative. Work done is positive if the force and displacement are in the same direction, and work done is negative if the force and displacement are in opposite direction. Now we know that the spring force is equal to minus k into x because the spring direction of the spring force is opposite to the direction of displacement and k is the spring constant. If we cut a spring into two equal halves, then each half, the spring constant of each half will be double. So from here, we come to know that the work done by the spring force is negative and the potential energy stored in a spring is half kx square. So I have told you about momentum, conservation of momentum, frictional force, inertial frame, non-inertial frame, about angular momentum, angular acceleration, angular velocity, torque, then kinetic energy, potential energy, and I have given you the examples which makes the theory more clear.